Littleton Coin Company is ringing in the holiday season with daily deals. Visit littletoncoin.com for at least 15% off select products now through November 28th. Save on your favorite coins, such as Morgan Silver Dollars, Kennedy Half Dollars, commemorative quarters, and much more. But hurry, each day offers a new deal you don't want to miss. Visit us now at littletoncoin.com. That's littletoncoin.com. Littleton Coin Company, serving collectors since 1945.
This is SpaceTime Series 25, Episode 68, for broadcast on the 22nd of June, 2022. Coming up on SpaceTime, a treasure trove of galactic information in GAIA's long-awaited third data release, Europe approves a new Comet Interceptor mission, and the brand new James Webb Space Telescope hit by a micrometeoroid. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The European Space Agency has finally published the long-awaited GAIA mission third data release. These findings represent the most detailed survey so far of our home galaxy, the Milky Way. The treasure trove of information provides a multitude of fascinating insights, including stellar DNA, asymmetric motions of stars, strange starquakes, and even new asteroid sightings in our own solar system. The GAIA spacecraft's mission is to create the most accurate and complete multidimensional map of the Milky Way galaxy. This allows astronomers to reconstruct our home galaxy's structure and past evolution over billions of years, and to better understand the life cycle of stars and our place in the universe. The importance of GAIA's Data Release 3 cannot be overstated. It contains new and improved details on almost 2 billion stars in our galaxy. The catalogue includes new information on stellar chemical compositions, temperatures, colors, masses, ages, and radial velocities, that is, the speed at which the star is moving towards or away from us. Much of this information is revealed through newly released spectroscopic data, a technique in which starlight is split into its constituent colors. And the data includes special subsets of stars, like those which change in brightness over time. Also new in this data set is the largest catalogue yet of binary stars, thousands of solar system objects such as asteroids and the moons of planets, and millions of galaxies and quasars outside the Milky Way. The data release represents a major step forward in science's creation of a detailed census of the Milky Way, fully characterizing a significant sample of its stellar constituents. Analogous to the Human Genome Project in biology, it allows astronomers to categorize hundreds of millions of stars, and that allows them to accurately determine their life cycles from birth to death, and to understand both the incredible history and future of the Milky Way galaxy as a whole. GAIA's chemical catalogue of some 6 million stars is some 10 times larger than previous ground-based catalogues. The GAIA data releases are telling scientists not just where stars are located and how they're moving, but also what they're made of. Unlike other missions that target specific objects, GAIA is a survey mission. This means that while surveying the entire sky and its billions of stars multiple times, GAIA also makes discoveries that other more focused missions miss. And one of the most surprising discoveries coming out of this new data is that GAIA was able to detect starquakes, tiny motions on the surface of a star that change the shape of stars, something the spacecraft was simply not originally built to do. Previously, GAIA had found radial oscillations, things that cause a star to swell and shrink periodically while keeping their overall spherical shape. But GAIA has now also spotted variations that are more like large-scale tsunamis. These non-radial oscillations change the global shape of the star and are therefore harder to detect. But GAIA found strong non-radial starquakes in literally thousands of stars. With this data release, GAIA is revealing the largest chemical map of the galaxy coupled to three-dimensional motions of stars, from those in our own solar neighborhood right through to stars in some of the smaller satellite dwarf galaxies which are orbiting around the Milky Way. And it makes for fascinating reading. GAIA's spectroscopic readings are providing detailed compositional analysis of thousands of stars. What stars are made of can tell astronomers about their birthplace and about their journey afterwards, and therefore about the history of the Milky Way galaxy as a whole. It all comes down to a star's metallicity. Different stars will contain different ratios of heavy chemicals known as metals. Astronomers refer to all elements as metals other than the hydrogen and helium which were present in the Big Bang 13.82 billion years ago. The difference is that metals are manufactured by stars, either during their lifetimes while they shine on the main sequence, or later when they die. And when stars die, they release all these metals, these elements, in the form of gas and dust, which then spreads through the interstellar medium between the stars and eventually goes on to be incorporated into new generations of stars. So as these new generations of stars are born, they are naturally richer in metals. Therefore, a star's chemical composition is a bit like its DNA, giving crucial information about its origin. With Gaia, astronomers have been able to see that some stars in our galaxy are made of primordial material, mostly hydrogen and helium, while others, like our Sun, are enriched with metals produced by previous generations of stars. It seems stars that are closer to the centre and plane of our galaxy are richer in metals than those at larger distances. And by looking at their chemical composition, Gaia was also able to identify stars that originally came from other galaxies, not the Milky Way. And so what stars are made of can tell us about their birthplace, their journey afterwards, and therefore about the history of our galaxy. This report from ESA TV.
Gaia's main objective is to determine the positions, motions, and distances of billions of stars. When the images of the stars from Gaia's telescopes move across the focal plane, their positions at a given time are determined by the light-sensitive astrometric CCDs. Subsequently, the light from the star passes through prisms, producing low-resolution spectra, helping us to determine, for example, the temperature of the stars. Finally, the diffraction grating and carefully crafted lenses in the radial velocity spectrograph disperse the light into high-resolution spectra, allowing us to determine the speed of the stars along the line of sight and their chemical composition. These stellar spectra, where the brightness of the stars is shown as a function of wavelength. Variations are due to the light absorption from atoms and molecules present in the stellar atmosphere. Most of the ordinary matter in the universe consists of the lightest elements, hydrogen or helium, created during the Big Bang. For all heavier elements, such as calcium and iron, astronomers use the word metals. Most of these metals were created by nuclear fusion in stars and given back to the interstellar medium, for example, by stellar winds and supernova explosions. In this way, our Milky Way is enriched in metals over the course of time. We are using the metal abundances derived from the RVS to colour the stars. Older stars should contain only a small amount of metals, while stars born later should have a higher metallicity. Stars with very different amounts of metals in their atmospheres towards the centre of our Milky Way. Gaia can detect dwarf stars with very low luminosities only if they're very close to us. Therefore, we now select only the very luminous giant stars in our sample, which can be detected by Gaia even at a distance of several thousand light years. We see that the enrichment in metals decreases as we move from the galactic centre to the outer galactic regions. This informs us about the chemical composition of the gas from which these stars were formed over more than 12 billion years of galactic history. Therefore, and thanks to the high level of detail of these Gaia observations, we can infer the rate at which the stars were born, the arrival of gas from the intergalactic regions, and the migration of stars inside the disk. The next sample consists of very young stars, only a few 100 million years old, and therefore about 4 billion years younger than our Sun. They are located along curves that reveal the spiral arms of the Milky Way where these stars were formed. The Sun is in a region outside the spiral arms. We see again the decrease in the metal enrichment as we look further outwards in our galaxy. This is the largest sample of young stars for which we have a detailed chemical description, thanks to Gaia Data Release 3. Because there are fewer of the young stars, we can show more of them individually. This allows us to visualize the motion of the stars as measured by Gaia. We see that the stars move together, illustrating the stellar motions in the disk of our Milky Way. To the plane of our Milky Way, these luminous stars allow us to determine the chemical profile of the Milky Way disk, including its older stellar populations, far from the galactic plane. As we move outwards from the galactic center, the disk density and apparent thickness decreases, like the chemical enrichment. In addition, in the inner regions, the stars near the galactic plane are more enriched in metals than the older stars, at higher distances above and below the plane. The stars in the spiral arms are located in the so-called thin disk, which has gas and ongoing star formation, and to which our Sun belongs. This thin disk profile becomes thicker as we move outwards from the galactic center. We show how these stars will move during the next 5 million years. Up to now, we have shown the overall global enrichment in chemical species in the atmospheres of the stars. However, we have also determined individual abundances of chemical elements. As an example, we color-code the amount of calcium in the young stars, an element which is, for instance, important for the stability of our bones. Finally, we show a group of stars that has no strong concentration towards the galactic plane. Almost all of them are very poor in metals. The stars were identified by their peculiar motion and chemical composition. They are the remains of a dwarf galaxy, called GAIA Enceladus, that merged with our Milky Way about 8 to 11 billion years ago. These stars illustrate that the galaxy in which we live is an ever-changing system, formed thanks to the assembly of stars and gas of different origins.
Gaia's third data release is also showing astronomers the speed at which more than 30 million stars in the Milky Way are moving either towards or away from us. This figure, known as radial velocity, is providing the third set of velocity dimensions in the Gaia map of our galaxy. Together with the proper motions of stars, that is, the movement across the sky, astronomers can now see how the stars move over a large portion of the Milky Way. It's providing a Doppler shift effect for the stars. Those moving towards us are blue shifted, with their wavelengths compressed to the blue end of the electromagnetic spectrum, while those moving away from us are red shifted, with wavelengths expanded or stretched to the red end of the spectrum. It's exactly the same effect as the change in pitch you hear from a train horn as it passes you at the station. This report from ESA TV.
The Gaia mission of the European Space Agency will accurately measure the space velocities of over 30 million stars in the Milky Way galaxy. Everything in our galaxy orbits around the center, very much like in a thin spinning disk. Stars closer to it travel on faster orbits and take less time to make one full orbit, similar to the way the planets orbit the Sun. The inner portions of the galaxy are dominated by the bulge with a central bar-shaped structure, an extended region with more stars compared to the outer regions. The Gaia team uses the new observations from space over a period of about 3 years for unraveling the kinematic structure towards the galactic center at some 26,000 light-years. The new Gaia observations reveal the velocities of stars of unprecedented quality, covering regions from the bar around the galactic center to the disk outskirts. Stars closer to the Sun are traveling at larger speeds. The new observations with Gaia reveal that stars in the bar have contracting and expanding motions around the central regions of the galaxy. A bar angle of about 20 degrees was also measured by Gaia. The Sun travels at a circular speed of about 240 kilometers per second around the galactic center, but it will take about 220 million years to complete one orbit. GAIA's third data release publishes the star velocities besides many other properties. GAIA's precision makes it possible to map the star velocities to much greater distances than were accessible before. The astronomers now see details in the velocities of stars at levels of precision that have never been observed before.
Other papers reflect the breadth and depth of GAIA's discovery potential. There's a new binary star catalogue which presents the mass and evolution of more than 800,000 binary systems, and a new asteroid survey catalogue comprising 156,000 rocky bodies digging deeper in the origins of our solar system. And again, let's go back to ESA TV.
As well as stars, galaxies, and quasars, Gaia also observes objects in our solar system, measuring their positions and brightnesses at different times. By far the largest group of solar system objects in Gaia's Data Release 3 are 154,741 asteroids, for which Gaia has determined the orbits. Depending on their orbits, one can distinguish different groups of asteroids. Most of the asteroids are in the main belt, between the orbits of Mars and Jupiter. Over a period of about 10,000 years, Jupiter's powerful gravity can perturb an asteroid's path so strongly that some of them become Mars crossers. Another group that is around the distance of Jupiter are the so-called Trojans. They are collected in two clusters, preceding and following the giant planet, but never getting close to it. If we move beyond the orbit of Neptune, we find trans-Neptunian objects. Gaia observed the brightest 24 members of this population. Back in the inner solar system, we find objects that come close to the Earth and sometimes cross its orbit. They were brought to the inner solar system from the main belt due to gravitational perturbations by Jupiter and other planets. Due to close encounters with the terrestrial planets, the orbits of near-Earth asteroids reach large inclinations with respect to the Earth's orbit and can also come very close to the Sun, where they experience strong heating. None of the known near-Earth objects is a danger to Earth in the coming decades, but it is very important to determine their orbits precisely.
Gaia is also revealing information about 10 million variable stars, about mysterious macromolecules between stars, as well as quasars and galaxies beyond our own cosmic neighbourhood. The Gaia third data release is one of the most important astronomical events to take place this decade, and astronomers will be sifting through the data for years to come. This is SpaceTime. Still to come, Europe approves a new Comet Interceptor mission, and the brand new James Webb Space Telescope hit by a micrometeoroid. All that and more still to come on SpaceTime. The European Space Agency has approved a new mission to intercept an interstellar comet or asteroid. The spacecraft, which could also target a pristine outer solar system comet just starting its journey into the inner solar system, will share a ride into space with ESA's Ariel exoplanetary mission in 2029. The project will build upon the success of ESA's Rosetta mission to the comet 67P Churyumov-Gerasimenko and the earlier Giotto mission to study Halley's comet. But both 67P and Comet Halley are short-period comets. These are bodies which have already swung round the Sun many times, and so have had their materials cooked up and transformed by the Sun's heat. The Comet Interceptor mission, on the other hand, aims to scrutinize a comet that has spent little if any time in the inner solar system, and may well be visiting our part of space for the very first time. Put it this way, while Rosetta's target hailed from the rocky Kuiper belt beyond Neptune, Comet Interceptor's target will either originate in the Oort cloud, more than 1,000 times further away from the Sun, or it will come from a different star system. Although they're much rarer, an interstellar visit from beyond our solar system, something similar to Oumuamua, which visited our solar system in 2017, would be a spectacular find. Studying such an object would allow astronomers to explore how a body would form and evolve in another star system, under what could be very different chemical and physical conditions. Comet Interceptor will be made up of a main spacecraft and 2 probes. The idea is to surround a visiting comet and observe it from multiple angles. In this way, this innovative mission will build up a three-dimensional profile of its as-yet undiscovered target. ESA will be responsible for the main spacecraft and one of the probes, while the Japan Aerospace Exploration Agency JAXA has agreed to develop the second probe. ESA's Comet Interceptor study scientist Michael Coopers says a comet on its first orbit around the Sun will contain unprocessed material from the dawn of the solar system 4.6 billion years ago. Studying such an object and sampling its material will help astronomers understand not only more about comets, but also how our solar system formed and evolved over time. Comet Interceptor was first proposed in July 2018 and then selected for further study in June 2019. It's an example of what ESA term a fast or F-class mission, one which would only take about 8 years from selection to launch. Typically, spacecraft for these smaller missions weigh less than 1,000 kilograms. It'll travel together with the Ariel exoplanetary mission to the Lagrangian L2 position, a gravitational well about 1.5 million kilometers behind the Earth as viewed from the Sun. Once there, Comet Interceptor will simply wait until a suitable target comes into sight. And once one is spotted and selected, the mission will fire up its thrusters and continue its journey. With recent advancements in ground-based telescopes, new comets are typically detected about a year or so before they make their closest approach to the Sun. Now, this is still short notice to plan and build a mission from scratch, but it would be enough time for the already in waiting Comet Interceptor spacecraft to travel from the L2 position to the comet's location. Comet Interceptor will characterize the comet's surface, composition, shape, and structure, and it will study the pristine material which makes up a comet for the first time, and investigate the composition of its gas and dust coma. And it doesn't end there. Comet Interceptor is also contributing to ESA's planetary defense efforts. Astronomers have identified 120 comets and some 29,000 asteroids that come close to Earth in their orbits around the Sun. And by studying these near-Earth objects, scientists get a better idea of the range of compositions and differing physics they represent, and therefore they can develop different strategies to try and defend against the next one on an impacting orbit. And the one thing we do know is that there will be a next one. This is SpaceTime. Still to come, the brand new James Webb Space Telescope hit by a micrometeoroid, and later in the science report, warnings that the current ongoing La Niña weather event could last until December. All that and more still to come on SpaceTime. NASA's brand new $10 billion James Webb Space Telescope has been hit by a micrometeoroid. Initial reports indicate the space rock impacted one of the hexagonal gold mirror segments which make up the 6.2-meter orbiting observatory. NASA says the telescope should continue to function normally despite the collision, which occurred sometime between May the 23rd and 25th. Micrometeoroids are tiny particles of rock in space, typically weighing less than a gram and often no bigger than a grain of sand. Mission managers say that after initial assessments, the team found the telescope is still performing at a level that exceeds the mission requirements. That's despite a marginally detectable effect in the data. James Webb's expected to deliver its first scientific observations next month. From its perch in the Lagrangian L2 orbital position, James Webb will look back more than 13.4 billion years, much further back than even the Hubble Space Telescope, back to the birth of the very first stars and galaxies. It'll also study planets orbiting other stars and search for signs of life in their atmospheres. Unlike Hubble, which sees in mostly visible light, James Webb will look at the universe with infrared eyes. That's because the objects it'll be looking at are so far away that their wavelengths have been physically stretched from the ultraviolet and visible light into the infrared by the very expansion of the fabric of space-time. Since arriving in orbit, James Webb spent the last few months aligning all its instruments in preparation to begin its scientific observations. The agency also confirmed that this impact event was actually the fifth micrometeoroid to hit the telescope, although none of the other four were anywhere near as big. Over the next 10 years of James Webb's operations, more and more micrometeoroids will hit the telescope, each one helping to further and further degrade the picture. NASA says micrometeoroid strikes are an unavoidable aspect of operating any spacecraft, and they were anticipated when building and testing the mirror. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. The World Meteorological Organization says the ongoing La Niña event, which has affected temperature and precipitation patterns across the planet over the past year, is now likely to continue until at least August and possibly even December. In fact, the WMO is warning that some long lead projections even suggest that it might persist into next year. If that happens, it would be only the third triple-dip La Niña since 1950. Now, this current La Niña event started back in September 2020, and it continued through to mid-May 2022 across the tropical Pacific. La Niña refers to a large-scale cooling of ocean surface temperatures in the central and eastern equatorial Pacific, coupled with changes in tropical atmospheric circulation, namely winds, pressure, and rainfall. The ongoing drought on the Horn of Africa and southern South America bear all the hallmarks of La Niña activity, as does the above-average rainfall in Australia and Southeast Asia, and predictions for what could be an above-average Atlantic hurricane season. The WMO says human-induced climate change amplifies the impacts of naturally occurring events like La Niña and is increasingly influencing our weather patterns, in particular through more intense heat and drought and the associated risk of wildfires, as well as record-breaking deluges of rainfall and flooding. Canadian researchers have found a link between living near fracking sites while pregnant and issues with baby development. The findings, reported in the Journal of the American Medical Association, are based on a study of 35,000 pregnancies over 6 years. Researchers found that living for 1 year pre-conception and or having a baby developed within 10 kilometers of at least one fracking site is more than likely to result in the child having major congenital anomalies and being small for the gestational age. Additionally, the study found that the risk of spontaneous preterm birth, as well as being small for gestational age, were increased in those living within 100 or more wells within that 10-kilometre border zone. The authors say the findings suggest that it's probably a good idea to be wary around any unconventional oil or gas development if you're intending on becoming pregnant. Paleontologists have identified the remains of a new kind of large-bodied meat-eating theropod dinosaur in the Bahariya Oasis fossil site of Egypt's Western Desert. The yet-to-be-named fossil, reported in the Journal of the Royal Society Open Science, dates back some 98 million years to the Middle Cretaceous. The remains consist of a well-preserved vertebrate from the base of the neck of an abelosauroid, a kind of bulldog-faced, small-toothed, tiny-armed theropod that's estimated to have been roughly 6 meters long. A choice investigation into Australia's 25 biggest and most trusted retailers has found that Kmart, Bunnings and The Good Guys are using facial recognition technology to identify customers in their stores. Facial recognition analyzes images from video cameras, capture a person's unique facial features, known as a face print. The practice is considered unethical. It's the same as collecting your fingerprints or DNA, and is considered an invasive technology to capture sensitive biometric information. That data can then be linked to your credit card at the checkout and on-sold to other companies linking other data sets about you. With the details, we're joined by Alex Zaharov-Reutt from ITWire.com.
Choice is an Australian consumer advocate organisation, been around for a long time, and they say that Kmart, which is the same sort of organisation that it is in the US, Bunnings, which is a hardware and garden supply store, and The Good Guys, which is a bit like Best Buy in the US. They're using facial recognition technology in some of their stores when you walk into the store. Obviously, they're doing that so they can see and profile the sort of customers they get, tell
who are the shoplifters, you mean?
Yeah, who are the shoplifters, but also who are the higher value customers. But yeah, But the thing is, customers don't realize that this is happening. There's usually a small notification on the side of sort of a large entryway that mentions things like, oh, we've got the right to check your bags before you leave the store. But the last line normally says words to the effect that you're being monitored not only by CCTV, but by facial recognition technology. And so consumers are largely unaware of the practice. And in Australia, privacy experts are raising the alarm, and Choice, the consumer advocate, says that they may be in breach of the Australian Privacy Act. So, this is capturing your unique biometric information, your facial features known as a face print. It's a little bit like as if they were, when you were walking in, they were taking your fingerprints off.
DNA or something like that, yeah.
Yeah, but I remember seeing this in, of course, sci-fi movies, Minority Report, where Tom Cruise's character was walking in. He had to get his eyeballs changed or his iris changed because of something that happened in the movie, some action thing. And when he walked in, it sort of said something like, Mr. Nakamura, welcome back to the store. Obviously, Tom Cruise is not Japanese. So, this is creepy and invasive, according to Choice. And, that's how some of the respondents were describing it. Others say they consider it unnecessary and dangerous, and they wouldn't want to enter a store that's using it. But look, it's still in its early stages, but it is predicted to increase as the technology becomes cheaper and more effective. And there's a bit of a concern, obviously, people are concerned with, us being the last generation that had privacy, and future generations won't have any at all. So if it's happening in Australia, it's probably happening in the US and elsewhere too, and certainly in China.
The thing that worries me most is what happens with that material later. Is that data on-sold to other companies, which then added to some giant warehouse profiling everything, every moment, every second of my life without my permission?
Well, that's right. It's being added to databases. Databases could be hacked. Some of the experts are saying, when they look at the Australian context, they see the creeping use of the technology without widespread public discussion. And, there are stronger border privacy protections in Europe where things like this are sort of going further. Organizations, governments, individuals, cyber criminals, people get more and more information about you all the time. They know if they can hack your health information, for example, they might know that you're allergic to, say, seafood or prawns, and they might engineer for something that you touch or eat to contain that. And, this sort of information can become a weapon, a bioweapon. Choice is saying that they believe that these retail businesses are disproportionate in their over-collection of this information, and it means that they may be in breach of the Privacy Act, and Choice is going to refer them to the Australian Information Commissioner on that basis. But really, we need a longer, larger conversation around this. And if this information is going to be collected, we need to be informed it's going to be collected. We need a way to camouflage our faces. We might have to wear a mask of some sort or simply say...
It's a baseball cap, it's a pair of large wraparound sunglasses, and the COVID face mask. That's how you get around that. That way there aren't enough biometric points left to get a good form of recognition.
That's right, but just as some people are receiving rebates from their solar panels on their roof, if this information is being sold, and I agree to it, where's my compensation for this information? Where's my cut? Why does everybody else get a cut but me? One of the other scandals that is sort of based on this is that modern TVs have a thing called automatic content recognition, ACR. Yes. They know what you're watching. They know what you're watching, how long you're watching it for, which channels, whether it's pirated or not. You have to turn that stuff off. Why should a TV manufacturer know anything about what it is you watch?
Because I'm aware of that. That actually influences what I watch and what I choose not to watch on TV.
Yeah, again, this information can be a tool for oppression, for bribery, for all kinds of things. No, you don't have the right to collect that information about me and exploit it.
That's Alex Zaharov-Reutt from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.